The random class is a class defined in the system namespace that allows us to generate random values. It is an instance class, so we create an object of type random to use it. In this case, I called the object rnd. Typing rnd dot will bring up the IntelliSense list showing what methods we can call, and besides the ones defined for all objects, we have next, next bytes, and next double. We'll start by looking at the next method, which allows us to retrieve a random integer. The first call returns a non-negative integer that is random. The second overload allows us to specify the upper bound for the random value that is returned. This upper bound is excluded, so if I typed in 100, I will get a value between 0 and 99. As a matter of fact, let's go ahead and do that one. And then I can do a console write line of value. So when it outputs this value, we should get a value between 0 and 99. And there's no way to really know what that value is going to be ahead of time, which is why it's random. If I want to specify a different lower bound than 0, I use the third overload, which allows us to specify the minimum value and the maximum. Now the minimum value is inclusive, so 50 can show up as a result. 100 is still exclusive, which means 99 is actually the highest value. Now I'll reprint the value out, and you'll see it's definitely above 50. What if I needed to retrieve a value between 1 and 100? Let's say we're creating a random number guessing game, and the choice for the user is to pick a number between 1 and 100. Well, we know when we called that first overload, passing it 100, we would get 0 to 99. So if we wanted to change that range to 1 to 100, we have two choices. We could use that second overload and supply 1 and 101 as the two possible range values. So 1 is included, but it's got to be less than 101, so 100 is the maximum value. That's one choice. Or the other choice is to retrieve a random number up to 100 and then add 1 to the result. So instead of the range being 0 to 99, our range is now 1 to 100. And I can once again print that value out. Now, an interesting thing about the random numbers that are retrieved from this random class is that it's not truly random. It's close, but it still is based on a mathematical algorithm that creates a list of random numbers at the time the constructor is called. That list of numbers is based on something called the base seed. When you don't pass in a value to the random constructor, the seed is going to be based on the current time. However, I can provide, let's say, the value 100 for my seed, and then watch what happens when I run it. I get 96, 57, and 67. Run it again. I get the exact same numbers again. So when I provide a seed value, that seed is going to predetermine that quote-unquote random list of values. So unless you are trying to replay some circumstance where you generate random numbers and you want to do it repeatedly in a test, I don't recommend supplying your own random seed, or use one that is based off something like the current timestamp. So I'll return that to a default constructor call. So it's pretty easy to retrieve an int value, but what if I want a decimal value, a double for instance? Well, then I can create a double called d and set that equal to rnd.nextDouble. and you'll notice there are no parameters for this call, and it will return a number between 0 and 1. And once again, that 1 is excluded from the output. Let's print out what that value is. There, it's 0.867. Run it again. And it's a completely different value. Finally, we have that last overload, which allows us to create a byte array with random values. So let's make it have 10 random values. So we create a byte array called bytes, then rnd.nextBytes, and then we supply the array. After this call, the array will contain a random list of bytes. So for each byte b in bytes, console.write. Let's take a look at what that list looks like. And click run. And there we have a random list of bytes. Starts with 128, then 72. So it's a value between 0 and 255. I will run it again, and it won't start with 128 this time, but it starts with 37. So this allows us to generate a random sequence of values. There is no limit to the size of this byte array. However, most of the time we use something like this to generate file names possibly, or just random keys to use for encryption. It is not necessarily something that you're going to use a lot in your programs, but when you do have to generate a long list of random values, you can use this nextBytes command to do it. One other thing I want to point out is when you create a random object in your program, it is recommended you do it using only one instance of random for the entire project. The reason is if you call this constructor rapidly, let's say it was in a loop, because the timestamp doesn't change as quickly as the processor may run, you may end up generating multiple random objects with the same base seed. And as we saw before, that will end up generating consistent random values. In other words, we are going to get repeated numbers when we probably don't want that. Let me demonstrate that really quickly. We'll create a for loop. I equals 0, I is less than 20, plus plus I. And inside this loop, we'll create a new random object. We're not going to supply a seed, we're going to let it use the timestamp. And then we're going to output a random number, 0 to 99. And we'll do that 20 times. So watch what happens when I run this. You'll see every single one of the numbers I retrieved is the same. They're all 28. I would have to probably increase this to something like 200 to see the number actually change. But you can see we have groups now. We have a bunch of 83s and a bunch of 47s, a bunch of 11s, etc. So if true randomness is what you're looking for, you definitely don't want to take this approach. So a common technique is to create a static class and maybe call it utils or utilities. Just make it a static class, and then you will expose a random object, you can call it RND, whatever you choose, from this class. Then this will only ever be constructed at the first time you utilize that static utils class, And then you don't actually have to create this in here. Every time you have RND, you would say utils dot RND. So now everything in the entire program can utilize the same random number generator and thus avoid the issue we saw in this for loop.